Hello and welcome to another episode of Generative Geek. We are continuing with our RAG series, Retrieval Augmented Generation. And in the last video, we covered the fundamentals. Today, I want to walk you through the larger project we'll be building as part of this series. So, the way we are looking at the RAG series is that, we are going to build an agent that will be able to take a lot of information from, let's say, various YouTube videos, various PDFs, and give you answers basis the extra knowledge that you share through these videos and through the PDFs. The way we'll work on this is that we'll follow a load, transform, and store data. That's the general cycle. You first load, you transform, and you store the data, and then you query that data. Whatever you get back, you add that to the prompt and send it downstream to the or upstream to the LLM. So in this project, when we talk about the load, transform, and store data, what we'll do is we'll first take these YouTube videos, we'll extract the MP3s from it, and then I'm sorry, and then using the OpenAI Whisper model, we will transcribe the MP3s. Now these are the audios. Let's say even if they are not MP3s, whatever is the audio, we'll transcribe the audios and we'll get the text back. So that text is called the transcripts. Now every model has a token limit, so you cannot go and push infinite content as part of the prompt. You have to honor the token limit, and in order to honor the token limit, the approach that is followed is that you take the text, you split and chunk it into smaller pieces, right? And then these smaller pieces, using some sort of a splitter that I'll show you as part of the LangChain library, you then take that and you convert them into vector embeddings. These vector embeddings are then stored into a vector database. We are going to use Chroma for our purposes. I already have a few videos on Chroma. If you don't know much about Chroma, it'll be a good time. Maybe today now is a good time to just go back, look at those videos, and very short videos, and you will quickly understand how to work with Chroma. Same with PDFs. We'll use some sort of a document loader, PyPDF loader or some loader, and convert what we get back into documents, and we'll then split and chunk these and store the chunks. Yeah. Then when it comes to retrieving, let's say a user types in a query, we'll take the user query, we'll convert it into vectors using the embedding function, and we'll push a lookup. We'll do a lookup on Chroma, right? That's where our data is stored. Chroma will return us back some documents. We'll add those to the prompt and send it down upstream to the LLM. With this more context that we are now pushing to the LLM, we will be able to get better answers from the LLM, which are more suitable for the kind of data that the LLM has probably not seen. Maybe these are YouTube videos that came out after the knowledge cutoff date, right? So the LLM has no idea about these YouTube videos. But the moment we start sending extra text, now the LLM has more information, right? So that becomes this these retrieved documents are assumed to be those which the LLM has not seen before or the model has not seen before, right? So this is largely what we'll be building as part of this series. But today, what I'm trying to do is, because this load, transform, and store with such a big project will take a while for you to understand. So what I'm doing is I'm taking it like a step by step kind of an approach here. So first, what we are going to do today is we'll build a simple summarization bot for large files. So let's say you have a PDF that is decently large, right? And that entire PDF cannot be sent in one prompt. So what we'll do is we'll load the PDF, we'll split that data into smaller chunks, and then we'll use some sort of a summarization method where we'll do stuff like and I'll show you what stuff and map reduce is. Stuff, for your knowledge, is for now is more about when you can send the entire document or the entire text as part of the prompt. Map reduce, on the other hand, is about taking those smaller chunks, summarizing them, and then taking all those summaries and generating a bigger summary out of it, like or a more mature summary of the entire document. And while we'll be doing all this, we'll enable Langsmith tracing. So Langsmith is an LLM ops tool by LangChain, and very useful. I am in love with it, and I'll show you how to do Langsmith tracing. So this is, the project that we are building. We will take a data source, we'll take some data, we'll load and chunk it, and then using LangChain and OpenAI, we are going to create a summarization bot, and then we'll see how the summary looks like, right? We are not getting into adding it to the prompt right now and then sending it down. So that's not the goal right now. The goal is just to coach you on the store, load, transform, and store pipeline, how to build that, how to think about it. That's what the goal is. So let's get started with the coding part of it. So let's get started with the coding part. I have an environment created. I'm not going into the specifics of how you create a virtual environment that we have covered in several videos in the past. Um, but now let's say the environment is created. I wanted to give you a glimpse of what all libraries we'll be working with. So we'll work with LangChain. We'll work with LangChain community, LangChain-OpenAI .env, IPyKernel, Streamlit, because at some point what we'll do is we'll convert all of this into a web app where you will be able to paste the URLs of YouTube videos, upload your PDFs and things like that, and requests for making external requests to the internet, and PyPDF, because PyPDF will be reading the PDFs. So now that I have the environment created, I'll just quickly run pip install -r requirements.txt, and this will install all the requirements that I have listed here, right? With this, what I'm going to do is, now that the requirements are almost getting completed, what we'll do, I'll quickly go to my Python notebook, and I'll say, and let's look at this PDF, right? What paper it is. And if you go there, like, you will see that this is the BERT paper. This is about the BERT, a model, transformer model that Google released. And this paper is all about that, right? So what we are going to do is we are going to take this paper, and then we are going to download this paper. I already have my environment created. These are the various libraries we are going to use. So for you, the first step after you have done your environment creation is just do a pip install -r requirements.txt, and for me it's saying, oh, everything is satisfied. But in your case, if you already don't have these libraries, you will find that the system pip will install these libraries for you, right? So once your requirements are done, I want you to now come to the env file, create a .env file, and within that have these four keys: OpenAI underscore API underscore key, LangChain API key, LangChain project, LangChain tracing v2, right? The last three keys are basically for the Langsmith tracing that we want to do. If you don't know how to get the LangChain API key, log into LangChain, go to langchain.com, uh, log in. I find the sign up button and I'm already logged in, but if you are not, then you will need to probably create an account. Once you are done with that, come to settings, and here you can see API keys, right? So this is the key that I am using. I'll be deleting the key before I publish the video, so it's okay. And next, what you should do is go to your OpenAI API key, and you should put your API key here. Uh, so I have added the key, and now let's come back. We will run this thing, run this piece of code. This piece of code is very simple. I just have this BERT paper URL, and I'm using request module to get this PDF, and I'm writing that PDF to the disk. So as document.pdf, once this is done, you can see a document.pdf has appeared here. So we are all set now. The document.pdf is available. Next step is for us to just go out and load import OS, load a few libraries. And what I'll do is I'll also import load from .env, import load.env, and find.env. These are the methods that will allow us to find the environment variables, right? So all those keys that we set up in our .env file, they will be looked up using this library, right? So we now have our necessary imports done. What will now go out is we will first load the document using the relevant document loader. Once the relevant document loader is done, we will next split the document as we had discussed. So in case of so for that to happen, what we'll do is I'll quickly show you how to think about it, because one of my aim with with these videos is to allow you, is to help you learn how to think about these problems, right? So just say LangChain PDF loader document, like you can say PyChain, LangChain PDF document loader, and when you come here you can see that there is something called as PyPDF loader, right? So I'm just going to copy this. I'm going to come back into my code environment and say, hey, I want to import this library, right? So we'll import this. This will give me a document loader, and because we are going to make use of OpenAI also, I'll just import that as well right now from LangChain underscore OpenAI import chat OpenAI. Okay, and we'll run this. Now both of these things are done. The other step that we wanted to do was basically, once the data is loaded, we wanted to split it into smaller chunks. Now the way you do it is that PyPDF loader, we'll see, will help us get the document loaded. Now we want to also split the document. So if you want to split the document, there is something called as a recursive, and we'll do the same thing. We'll say a LangChain recursive character text splitter, and recursively split by character. And if you do this, you can see that there is something called as LangChain text splitter import recursive character text splitter, and you have to give it what is the chunk size, how much is the chunk overlap, and all that. And we'll do the same thing here. So we'll first import. We'll say from LangChain underscore text splitters import recursive character text splitter. Now with this, all our imports are done, at least for now, and we still haven't done the summarization part, but that we will load in a while, right? So I'll run these imports. Once these imports are run, next step is very simple. What we'll do is we'll first load the document. So we'll say we'll create something called as a loader, and we'll say loader is equal to PyPDF loader. And remember, for PyPDF to work, it needs to have, for PyPDF loader to work, it needs to have this library called PyPDF, right? If you don't have this in your requirements.txt, it will give you an error, right? And once we have done this, we'll say import document.pdf, right? So that's the file name uh, that we just downloaded. So we'll do this. We'll then say pages is equal to loader.load. Or you can, what we are doing is we are creating a loader, and then we're saying, hey, now load those documents. So we'll run this, and if you just do a len of pages, it should be the number of pages that this document.pdf has. If we go back to the paper, and we can see that there are 16 pages in this paper. So this is all right. Sorry, our len of pages is 16. That means 16 pages of this PDF got loaded. Now let's quickly look at some of these pages. Maybe we'll say pages 2 to 3, and we can see that this is some page that has got loaded. If you look at it, the object is of type document, and that's what the document loader is trying to do, right? So the one beauty of LangChain document loaders is that whatever you load, you could load a YouTube video, you could load a PDF, you could load some, you could transcribe something, and there are various custom document loaders that are built by third parties. All of them will bring a document, right? So this is a document. Now that we have the document, as per what we were trying to do, our next step is basically to just go out and and now split the data into smaller chunks, right? So let's do that. What I'll do is I'll use a splitter that we call recursive character text splitter, and like we did earlier, what we'll just go to LangChain. I'll type LangChain recursive, second, I'll just zoom this, recursive LangChain recursive text character text splitter, sorry, recursive character text splitter. And we'll just go look at this page, and I can see that I can import it using from LangChain underscore text underscore splitters import recursive character text splitter. So this is what we'll do. I'll quickly come back to my code, and we'll say from recursive langchain underscore text underscore splitter import recursive character text splitter. We can also import it from langchain dot text underscore splitters, so even this is valid. um, okay, something is not right. Maybe I don't have it in my do I have langchain community installed? Yeah. Okay, so I'll not get into this right now because my goal right now is to help you understand. So from langchain underscore text underscore splitters import recursive character text splitter. Once we have this import done, what we'll do is we'll come back and create a split, right? So I already have my pages. Now if you look at the character text splitter that is shown here, a recursive character text splitter takes a chunk size and a chunk overlap value, right? So we have to basically give it a chunk size and a chunk value. And in order to do that, what I'll do is I'll say chunks, or first let's just create a text splitter. We'll call it the text splitter is equal to recursive character text splitter with chunk size is equal to 1000 and chunk overlap of 100. Yeah, so with this my text splitter is ready. And now what I'll do, we have already loaded the pages, we have seen how the pages look like. Now I want to pass these pages to the splitter and get the documents out. So because these are documents, what we'll say chunks is equal to text underscore splitter dot split documents. And you can see, the code completion, there's also split text and there is split documents. If it was just a string, we would have used split text, but because this is like a document, I'm using documents. So, and we'll give it all the pages. With this, I get back some chunks, and now I'll let me just print um, split len of pages. I'm trying to see how many pages were there into split pages into len of chunks, right? So it has split 16 pages into 78 chunks, right? And if you just want to go and see how the chunk looks like, maybe I'll just load the third chunk. This is how it looks like, right? So and maybe a fifth chunk. You will see these are how the chunks look like, right? Now let me just do this. Let me quickly go and increase the size of the chunk. So from 1000 I'm making it 2000. We'll run this again. Now if you see, that 78 became 41. So depending on how big your chunks are, and now if we look at the same chunk 3, chunks 3, you can see that the chunk is much larger, right? So it is no more a small chunk. And this is what chunking is doing. Now that the chunking is done, let's create our LLM, and we'll use chat OpenAI, and I'll set the temperature to 0. Right, so our LLM is ready. So far what has happened is our LLM is ready. If we go back to this, our LLM part is ready, our this is ready, our load and chunk is done. Now we have to bring in LangChain's chain and OpenAI together to come out with the summary, right? So that's what we are going to do now. So our LLM is ready, our chunks are ready, our pages are loaded. So what do we do now? We'll use what we call the chains, and I want to use a summary chain, LangChain, and I'll just do a Google, right? So I get the first result I get is summarization, right? And if you look at this summarization, this document, it tells you some very interesting stuff. Like, and it talks about a load summarize chain. And this load summarize chain, what it does is it takes two types of approaches are available. One is called the stuff approach, and the other is called the map reduce approach. Now, the stuff approach, if you look at it, is what the stuff approach does. It takes the documents, it will take your chunks, and it will pass all those chunks as part of the prompt. It is not going to say, hey, you know what, let me just send 5 chunks and then send the 5 next time, right? So it's going to send all the chunks. So you have to use this approach, the stuff approach, when your token size allows you. And I'll show you what happens when you just do it, right? So if your token size doesn't allow, right, you have to use a different approach. And LangChain has another approach called MapReduce, and in that, what happens is you create your various chunks. If you look at these are various chunks. You send each chunk as part of a prompt to the LLM, and you create various summaries. And then you send these various summaries as part of the prompt to the LLM, and you get a final summary. So it's a very step-by-step process. You take each chunk, and I'll show you on Langsmith, and it's a very interesting thing that you will learn today if you already don't know about it. So let's just go back to our code window, and we'll say what we want to do is we want to use the chain, right? So we'll start using the chain, and I'll call it the summarization chain. Summarization chain is equal to, and before we can use the load summarize chain, we'll have to import it. So let's quickly look at this and figure out where we have to import this from. So it comes from langchain.chains. So I'll just start loading it from langchain.chains.summarize, import load summarize chain, and I'll now call it load summarize chain. And in this, we'll have to now pass, because it's a chain, and LangChain chains generally take two important things. One is what is your LLM. So we'll say LLM is equal to LLM, and we'll pass chain type is equal to stuff. So I'll use stuff for now. With this, the summarization chain is ready. And now all we have to do is we have to say result is equal to summarization underscore chain dot invoke, and we'll pass in all the chunks, right? And let's see what happens, right? So I'll pass this, and I get back an error. It says this model's maximum context length is 16385 tokens. However, your message resulted in 18340 tokens. Please reduce the length of the messages. Right. And now if we come back to our LangChain, let's just go to Langsmith and see what happened. I'll go to LangChain, Generative Geek demo. And if you see here, there is a stuff documents chain that we were using, right? This is the request I have just made. And stuff documents chain, if we open it, we get back an error. This model's the same error that we saw on our visual code, right? And here you can see there was an LLM chain, one single chain with one single chat OpenAI call. And this call basically has all of this in the input. So this is the beauty of it. You can actually, beauty of Langsmith, you can see what is happening under the hood, right? And you can see that it basically sent the entire paper. The prompt was write a concise summary of the following, and then this entire paper came up, right? And you got an error back. Now let's use, and I can show you, if let's just say we reduce the chunk size. Let's say we don't send all the chunks, and we say, hey, you know what, let's not send all the chunks, but let's send only the all of the chunks except for the last 10 chunks, right? So let's say except for the last 10 chunks, we send everything up. Again, come back to LangChain, Langsmith, and you can see that there is a stuff document chain that is going on right now. Again, we go inside, and we can see there is only one call that has been made, and again the same thing, except that this time the call has gone and we got an output back. This paper introduces BERT. And if we come here back on our code, wherever guys you want, please feel free to pause the video and look back at the stuff. This paper introduces BERT, feature based approaches, right? Feature based approaches, glue, squad, squag, swag. You can see all of this is here, right? So this Langsmith is also capturing the model's output before you can see it here on your visual code, right? So with just 10 less chunks, we could get this done. But then in a way, what happened is you are not past the entire document, right? Now, how do we do if we had to pass the entire document? For this, the way to do it is we'll create the new type of chain, and we'll call it the map reduce chain, map underscore reduce, right? So this is our new type of chain. We'll do the same thing. We'll say result is equal to, and we'll pass in all the chunks, not just, and we'll start this chain, right? So let's come back again here to our Langsmith, and you can see a map reduced documents chain has started this time, right? And look at how many calls are going to chat OpenAI, right? And if you just open one call, you can see, okay, this is what this call is about. This it has, because our chunk size is 2000. So there should be roughly 41 calls that have gone, and you will see each call has a very different input, right? uh, Input output representations, Finally, what will happen is all of these calls will result in some summary, right? So because what we are asking, we are saying, hey, write a concise summary. So you will have maybe these 41 summaries. LangChain will then make another call with these summaries and say, hey, you know what, now give me reduced summary. So that's what map reduce is all about, right? And let's wait for this to happen. It usually takes like a minute or two. We are up by around 58 seconds already. I am expecting the result to come anytime now, and we will probably also be able to see it here. And if you look at just the things that are available with LangChain, right? You know, with Langsmith, you can see how many tokens are getting used, what was the total cost, uh, and the reason I'm not showing you the refined documents chain, I have already done one sample call in my free time, and look at the latency, right? 2937 seconds. It used a lot of tokens. It obviously generated a good output, but this is how the refined documents chain looks like, right? You know, it takes a lot of time. It keeps improvising the prompt, so it says write a concise summary of the following. And then if you look at the further calls that go, so each call is an improvement to the previous call. That's how this works, right? So your job is to produce a final summary. We have provided an existing summary up to a certain point, right? So what it is doing is it is saying, hey, you know what, I'm giving you a summary up to a certain point. Now go out and refine this summary further. So it goes out and refines the summary further, and this is, you keep doing it, keep doing it, till with all the chunks are done. And that's how refine works. Like refine is another method. If you go back to LangChain summarization we were talking about, there is another method they talk about here, which is called the refine method, right? So I'm not talking about it right now. This is the refined method, but I'll highly encourage you do this in your own free time, and use Langsmith, because it will really help you understand what is happening behind the hood, right? So our map reduce document is done. It took 98.56 seconds, so 1.5 minutes roughly. Let's go back to the code and now print result output underscore text. Yeah, sorry. Yeah, the BERT model is a language representation model that can be fine tuned and all of that, right? So you look at this, you sent a very large PDF. That large PDF, so what have we done? We basically loaded a large PDF, and like this, you can keep loading super large PDFs, like, you know, maybe say why 16 pages. Let's load a 100-page document, right? Convert it into chunks, send each chunk. And the way you convert, this is my preferred way, recursive character text splitter. There are more splitters available. If you just go to LangChain and type LangChain splitters, you will see that, you know, there are tons of splitters available. Split by HTML, markdown, a lot of splitters are available. These are all the types of splitters that are available. It also has code splitters. So have a look at them, play with it. You will learn a lot in the process. So guys, today what have we done? We So far we have not done the Streamlit part. I have not made it into a web app. That is something that we'll hold on for a future video. But it's very easy, right? If let's say you are building a Streamlit app, instead of sending this thing through a through a Jupyter notebook, we could have just said upload the document. We would have read the document using the exact same code that we have done so far, and this output then we would have shown as a Streamlit app, right? So that we would have done. So yeah, I hope this made sense. And this is it. Now in the next video we'll get started with our project, where we'll say, okay, now that you know about the document loading and splitting into chunks, let's get ahead with even different, with more types of loaders. Like, you know, we have covered the PDF loader, but we'll probably use more PDFs in our next video, and a larger PDFs. And here, this is a YouTube video, so we'll take different type of a loader next time, right? I hope it made sense. Until next time, please do comment if you have if you like the video, if you learned something new. Do like, subscribe, send a comment. It will really, you know, be useful for me to understand if these videos are, like, you know, of use to you or not. Thank you so much. Good day.